special angles and the unit circle. So a circle is defined by a set of points that are equidistant from a fixed point called the center. The distance between any point on the circle and the center is called the radius. A circle of radius r and center 0, 0 is shown below. The point xy lies on the circle. Draw a right triangle in a convenient position and use the Pythagorean theorem to find the relationship between x, y, and r. So there's a radius. This is r. We draw a perpendicular line down. So this will be x, and this will be y. And what's the relationship between x and y and r? Yeah, x squared plus y squared equals r squared, right? So we have a right angled triangle. So the Pythagorean theorem says x squared plus y squared equals r squared. The equation of a circle with radius r centered at the origin is just that. It's x squared plus y squared is equal to r squared. Write the equation of a circle centered at the origin with radius 5 units. So what would that be? Instead of r, you're going to put in, what, 5? So we would first write, excuse me, x squared plus y squared is equal to 5 squared, or x squared plus y squared is equal to 25. Write the equation of a circle centered at the origin with radius 1 unit. So what would that be? Yeah, x squared plus y squared is equal to 1 squared, or just x squared plus y squared equals 1. A circle centered at the origin with a radius of 1 unit is called the unit circle. Okay, so the important thing about the unit circle is the radius is 1. Why is that important? Well, remember our special triangles here, so use your knowledge of special angles to determine the values of x and y. So we know that sine 45 is what?
1/2. No.
Okay, well, what's the definition of sine? The x, y, r definition. So sine theta is equal to what? Mm-hmm. But what's the x, y, r definition, not the y over r, right? Opposite over hypotenuse only works if that triangle happens to be in the first quadrant, right? But if it's in any other quadrant, then sine theta is y over r. So we've got sine 45 is equal to y over, well, say r. Now we know the sine of 45 is root 2 over 2, and that's equal to y over 1. So it just says y is equal to root 2 over 2. What's x equal to? Root 2 over 2, right? I mean, it's an isosceles right triangle, so x and y are the same. Okay. So since the triangle is isosceles, x is equal to y, so x is also root 2 over 2. And we could also have done that with cos 45, right? But cos 45 is the same as sine 45. 30 degrees. Okay, so sine theta again is y over r. We won't write the formula down again. We did it once. So we'll say the sine of 30 degrees is y over 1. Sine of 30 degrees is a half. 1/2 is equal to y over 1, or just 1/2 is equal to y. Right? And better stated, y is equal to 1/2. For x, well, it's not an isosceles triangle, right? So x and y aren't the same. So now we got to go with cos of 30 degrees, or cos theta, is x over r. The cos of 30 degrees is x over 1. Root 3 over 2 is equal to x over 1, or just x, right? So we got to know our angles, right? We got to know the sine 30 is 1/2, the cos 30 is root 3 over 2. So x is equal to root 3 over 2. And now let's go look at 60 degrees. Okay, so the sine of 60 degrees. So basically what we're doing here is we're taking pieces of the unit circle, right? Because we made the radius equal to 1, so this is really just a chunk off of the unit circle. So sine of 60 degrees is y over 1. The sine of 60 is root 3 over 2. So y is root 3 over 2. And cos of 60 degrees, which is x over r, is x over 1. 1/2 is equal to x, so x is 1/2. So we're using special triangles. We're setting it up so that the radius is 1, and then the interesting thing that happens because of that, because sine theta is y over r and cos theta is x over r, we're just putting them over 1. So it means sine theta is just equal to y, and cos theta is just equal to x. So if we're working in the unit circle, x is cos theta, whatever the x value is. Y is sine theta, whatever the y value is. Now we are going to go to this unit circle. Unit circle is shown below with some points on the terminal arms of angles that are multiples of the special angles 30 and 45 degrees. Right? So 30, 45, 60. Label the measure of these angles and use your answers from question 4 and symmetry to state the coordinates for each of the indicated points. Okay, so I'm going to have to shrink that down a bit. Views, I don't know, let's try 125. Nope. A little smaller. 100%. Okay, that'll do it. So, what we can imagine doing is just drawing in 30-degree triangle. Now we know that r is always equal to 1. We know that the cosine of 30 degrees is the x value from that 30-degree triangle, which is on the left-hand side. It's on the left-hand side of your page there. Here's how I memorize the unit circle. Okay? And here's how you too can memorize the unit circle. Okay. Now, really, all you need to know is the first quadrant, because after that we can use symmetry. So you need to know 5 numbers. You need to be able to count. Okay. It starts at 0 and it ends at 1. So not too hard. That's 2 of the 5 numbers. The next one is 1/2. So you go 0, 1/2. Now we've got those special numbers, right? And we're just going to take them in order. So in order, smallest to largest, 0, 1/2, root 2 over 2, root 3 over 2, and 1. Okay, so 5 numbers in order, 0, 1/2, root 2 over 2, root 3 over 2, 1. So here's how it looks. So if I go to this point here, what's my x value? 1. And what's my y value? 0, right? There's no up or down. If I go here, this is 90 degrees, right? What's my x value? 0. What's my y value? 1. So here's what we're going to do. We're going to count from 0 to 1. I'm going to start with the y values. Go 0 and then just start going up, right? Because the y values are going up. So it's 0, 1/2, root 2 over 2, root 3 over 2, and 1. And then I'm going to start at the top and count my way down. But remember, as I go this way, my x values are getting larger. So 0, 1/2, root 2 over 2, root 3 over 2, and 1. Okay, that's it. All you got to do is memorize 5 numbers in a row. 0, 1/2, root 2 over 2, root 3 over 2, and 1. Start off by labeling this point at 0 degrees, which is 1, 0, and this point at 0, 1, and then just count from 0 to 1 with the x's, getting larger as we're going this way, and start 0 to 1, counting up as we go that way. Okay, that's it. Every question you need to do in trig for now and next year can be done using the numbers that you have there. That's all you really need. Okay. Now we can fill in the rest of the unit circle. We're just going to use symmetry. Okay, so here, we could say, well, theta is equal to 30 degrees, right? And we've got our x value, and our y value, and this is just 1, and all of that, right? But we saw that on the previous page, right? Cos theta is x over r. Since r is equal to 1, cos theta is just equal to x. Now, if we want to keep counting our way around the circle, so we should start to, we'll just label the rest of these angles, right? So 30, 45, 60, 90. So why don't we do the 45s first, right? So the 45s are just taking each quadrant and cutting it in half, right? So let's go multiples of 45. 45, 90, what's next? Going to be here, halfway. 90 plus 45. 135. 135 plus 45. 180 plus 45. 225 plus 45. 270 plus 45. 315 plus 45. 360, right? 0, 360. So just counting my way around by 45s, right? Which is a half of a quarter, right? So the circle split into 4 parts. Unit circle split into 4 quadrants, right? So 0, 90, 180, 270, back to 0 or 360. Split that in half, 45. Split this one in half, 135. This one in half, 225. This one. Okay, now we'll just count by 30. So we got 30, 60, 90, 120. Good. What kind of sequence is this? Arithmetic sequence. 120. What's next? 150, 180. What's next? 210. What's next? 240. What's next? 270. 300. And 330, and then 360, right? Okay, so take the circle, split it into 4. It's 360 degrees around a circle. Why? I blame the Babylonians. I think it's their fault, but I'm not entirely sure. But at some point, somebody decided 360 was a nice number to split a circle into. And I mean, in a sense, it kind of is, right? Because then we get these 30, 45, 60. Lots of other numbers go into 360 as well. 1, 2, 3, 4, 5, 6. Can't do any better than that. 1, 2, 3, 4, 5, 6. Not 7, not 8, 9, 10, not 11, 12. Anyways, so split it into the quadrants, 90, 180, 270, 360. Split the quadrants in half, 45, 135, 225, 315. And then just go around counting by 30s, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Nice little arithmetic sequence. Now what we want to do now is use symmetry. So symmetry is just really reflection, right? So I'm taking this point here, root 3 over 2 1/2, it's going to reflect over here. But when it does that, what happens to it? The x goes left, so the x is now negative. So this will be negative root 3 over 2 and positive a half, right? My y values are still above the axis, right? So the y values are just going to stay the same. So this will be root 2 over 2, and this will be root 3 over 2. And what's going to happen to my x values? They become negative. Okay. And it's a reflection in the y-axis. That's more next to your country, the idea that a reflection in the y-axis, you make the x negative. We know reflecting in the y-axis, right? You make the y value negative. Or sorry, reflecting in the x-axis, you make the y values negative. Where's 180? Negative 1, 0. Okay, so if I want to get this quadrant, I just take these guys and reflect them down, right? So the 150 goes with the 210, right? Same distance, right? They're the same x distance, right? They're this far, and the y values are, so what's the y value for 210? Negative a half, right? So what's the coordinates? Well, it's negative root 3 over 2. The x values are the same. And it's a reflection in the x-axis, so the y value, which sort of lost the negative sign. Negative root 3 over 2, negative 1/2. Okay, so fill in the rest. When you go here, what happens? Your x values are the same. Your y values are negative. Okay, so try to fill in the rest of the unit circle, as I will as well, and then and you can still just do the idea of the counting, right? Count from 0 to negative 1. So 0, negative a half, negative root 2 over 2, negative root 3 over 2, negative 1. Let's count from 0 to negative 1 going here. Negative a half, negative root 2 over 2, negative 3 over, let's count from 0 to negative 1. 0, negative a half, negative root 2 over 2, negative root 3 over 2. Let's count from the x values. Let's go from 0 to 1. So 0, a half, root 2 over 2, root 3 over 2. Let's go from 0 to negative 1 with x values. Negative a half, negative root 2 over 2, and so on, right? So symmetry, counting, whatever. So you can, if you choose, fill in the entire unit circle. If you get good at it, you can fill it in like a minute or 2 minutes, right? It doesn't take long to fill in. Okay. What you really have to memorize is just this first quadrant. That's all that's needed to do any trig in high school, right, is the first quadrant. If you have the whole thing, it's kind of handy, right? So on the next page, we're going to answer like 100 questions on different stuff. It's really handy. You can just look at the whole thing. It's easier to do, right? So it becomes, on any exam or anything like that, it's a cost-benefit analysis, right? What's the cost of drawing out the entire unit circle versus how much am I going to have to use it on this test? Right? Now, if I really only have to do 2 or 3 exact angles, maybe it's not worth drawing the whole thing out, right? But if I have to do a whole bunch, or it's grade 12, it's the, diploma exam in 30-1, maybe I want to pull out one of the tear-out sheets, take 2 minutes at the beginning, draw a complete unit circle, and have it there to refer to, and not have to worry about having to think it through, and potentially get something wrong. Okay, any questions on drawing the unit circle? Okay. Next year you get to do it in degrees and radians, whatever these radians are. But which you have not used and will not use for a while. But they're angles that make sense, unlike 360 degrees, right? Why 360? Why not? Okay. Now, recall that for any point xy on the terminal arm of theta in angle standard position, that cos theta is x over r, sine theta is y over r, where r is the distance from the point to 0, 0. For all the above points on the unit circle, r is equal to 1. Therefore, cos theta is blah, blah, blah. You know, it's what we already talked about, right? The x value is cos theta. The y value is sine theta. So for each point on the unit circle, the coordinates represent cosine, comma, sine, right? So if you draw the unit circle, you're looking at cosine, sine. If theta is an angle in standard position and xy is a point on the unit circle that is also on the terminal arm of theta, then xy is cos theta, sine theta. Use the fact that tan theta is y over x to determine the tangent of each of the above angles. The above angles are the angles that are on the unit circle, right? All right, so we got to do the tan of 30. So I'm going to show you a way to do tangent just looking at the unit circle, right? Show you the hard way and then the easy way. All right, so looking at 30 degrees, right? So we'll just go down here. So we'll say for 30 degrees, point on the unit circle is root 3 over 2.5, right? Okay, so that's x comma y. We know that tan theta is y over x. Okay, so tan theta is y over x. So tan theta is, so y is 1/2 and x is root 3 over 2. Okay, nothing shocking here, except it's a fraction over a fraction, which is kind of eh. So what do we do? Because we got a fraction over a fraction. Multiply by the reciprocal, right? So tan theta is 1/2 times 2 over root 3, right? So some call it kiss and flip, whatever, multiplied by the reciprocal. What happens to the 2's? They cancel. So we get 1 over root 3, which is what? Root 3 over 3, right? Because we can all rationalize 1 over root 2 and 1 over root 3 and that, right? Without great. Okay, so tan of 30 degrees, okay, actually here I should have written 30 degrees, right? Tan of 30 degrees, and here the same thing, the tan of 30 degrees. Okay, so that's the hard way. Do you want to know the easy way? Here's the easy way. Let's go back here. Here's what you do. You say, I'm going to take half. Now, notice, what's in the denominator here, 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 here? It's always 2's, right? So what's going to happen when you take y over x? You're always going to flip the x and multiply, and the 2's are always going to cancel, right? So here's the easy way. You take the numerator of y over the numerator of x, right? So tangent is 1 over root 3 or root 3 over 3. Tangent is, what's tan? Root 2 over root 2, which is just 1. Tangent is root 3 over 1, which is root 3. Okay, the rest of them are symmetrical, right? They just change the sign. Okay, so you need to be able to do two things. You need to know the first quadrant of the unit circle and the cast rule, right? Those two facts, good enough. You can do any angle using those two facts, right? Because if you say, and reference angles, so three things, right? The first quadrant of the unit circle, reference angles, and the cast rule. You have that, you can do any of these guys, right? What's the tan of 150? So you say, okay, the tan of 30 is root 3 over 3. 150 has a reference angle of 30, so the tangent's the same, but it's in quadrant 2 where only the sine is positive, so the tan is negative, so it's negative root 3 over 3, right? So the tan of 30 is root 3 over 3, tan of 150, it has a reference angle of 30, it has the same value, but it has a negative sign, right? So it's negative root 3 over 3. We will emphasize this much more next year, right? But even now, right, you draw a unit circle out. So any of the tangents there, you just do the exact same things, right? It's y over x, but easy, right? It's the numerator of y over the numerator of x. Okay? So that's going off on a tangent. Use the unit circle above or on the previous page. Wow. What happened? All right, that went away. Use the unit circle above to state the exact value of each of the pod. So when we say exact value, how many decimal points is that? None. It's a fraction. Like a half. That's the only one you actually could express as a decimal, or 0 or 1. Okay? So, here are all the exact values you have to deal with. 0, 1/2, root 2 over 2, root 3 over 2, 1, root 3 over 3, and root 3, right? Because the tangents also have that, right? So those are the numbers. And next year I'll show you a way you can fake your way into it without actually knowing it. You can just use your calculator. Okay, I'll tell you now. You can if you memorize the decimal equivalents of 0, 1/2, and 1, which are pretty easy because they're 0, 0.5, and 1. And if you know root 3 over 2, which is what's root 3 over 2? It's 0.8667 or something. And you know root 2 over 2, which is 0.7071, right? So if you do like if you do sine 60 and you see 0.7071, you could say, or sorry, you'll see 0.8667, you say, oh, that's root 3 over 2. Right? So if you memorize the decimal equivalents, you plug it into your calculator and go, what's the sine of 135 degrees? And it says negative 0.7071. You go, oh, that's negative root 2 over 2. Okay, so the other one is root 3, which is 1.717, and root 3 over 3, which is 0.5 something. Okay, not 0.5, but 0.5 something. So if you memorize decimal equivalents of 0, 1/2, root 2 over 2, root 3 over 2, 1, root 3 over 3, and root 3, then you can just plug it in your calculator. You know, it's easier to do the unit circle. Trust me, it's a whole lot. Because in calculus, you will not have the calculator available to you, so you're going to have to know them, right? So don't get relying on, oh, I'll just use the calculator, because it won't always work. All right, what's the sine of 120 degrees? Root 3 over 2. What's the sine of 315 degrees? What's the sine of negative 9? Oh, where's negative 90? 270, right? So if you have a negative angle, you can just convert it to the principal angle. Remember, the principal angle is the smallest positive angle between 0 and 360. So I could just add 360 to that, or I could just say just rotate 90 degrees, going which way? Clockwise, right? Instead of counterclockwise. So negative rotation angles are clockwise. So I just rotate 90 degrees clockwise, and what do I get? Yeah, 270, and what's the sine? Negative 1. What's the sine of 210? I'm not even looking. Right? I know this stuff. Okay. So that's the thing, right? When you know this stuff, you know, how do I do this, right? I just look at it and I say, 210 has a reference angle of 30 degrees. So it's the same as sine of 30, but it's in quadrant 3, where sine is negative, so it's the sine of 30 degrees, but it's negative, so it's negative 1/2. Okay. That's where you want to get to that point. Right now, just worry about, I've got the unit circle here, I'll work off the unit circle. Okay, what's the sine of 225? Oh, sorry, negative 225. Root 2 over 2. Okay. Go fill in the rest, right? Or do the next line, because the next line is just some cosines and stuff. Then we'll worry about tangent in a sec. We'll go back, we'll look at tan. Just make sure you got that down. So all you gotta do is flip the page, right? So cos of 60, cos of 210, cos of negative 30, cos of 135, cos of 180. No, wait. All right. Now, make sure that's right, because I'm just doing that from memory. Okay, I didn't actually memorize all those. I only know the first quadrant of the circle and the cast rule and reference angle. Okay, is that line right? Yeah, no, ooh, we're not there yet. Hang on, we got to keep flipping the page. You know this stuff, we don't. That's good. You wander in a calculus class, and I'll be saying so like, well, actually we use radians there, but I'll be saying, what's the cos of this, right? And then they'll just shout out, 1/2. Okay, great. What's the sine of this? Sometimes I cheat and I draw a diagram, but not a unit circle. Okay, tan of 135, right? So how do we do that? So we look at 135, we want to take the y over the x, right? And we get what? -1, right? We get negative root 2, sorry, y is positive root 2 over negative root 2, which is -1. Tan of 300 is, I know it's negative, and I know it's the same as the tan of 60, so it's like what, -√3? Tan of 90, it's y over x, it's 1 over 0. What's 1 over 0? Undefined. So the tan of 90 is undefined, right? Because you're trying to take 1 divided by 0. You can't divide by 0, right? Where's the NHL rec? Can't do that. Okay, tan of 120, it's negative. It's the same as the tan of 60. Tan is -√3, right? Is that right? Yeah. Tan of -360, okay, that's the same as the tan of 0, which is just 0. So if you get a negative angle, you can just convert it to a positive angle, right? Add 360. What's -360 plus 360? Nothing. 0. 585, right? This is really where you want to start using reference angles, right? Because 585, I don't know, but subtract 360 and what do I get? 225. Tan of 225 is +1. Okay, so fill in the rest of the line. Check my work, because I'm just doing this from the top of my head. -510. -210, -150, 210. -120. That's 63. And cosine of -270. Okay. Check and make sure those are right. So take answers off the unit circle, right? I mean, this might be something on the test which is coming up whenever the test is coming up. Or somewhere there's Friday, June the 5th. Right? So you might want to sit down, take a piece of scrap paper, draw out the entire unit circle, have it there, handy, ready to use, ready to say, I want to work off of this. All right, so why is this useful, right? Well, it's useful because we can get exact solutions and we can solve stuff like this. So, solve each equation for theta, where theta lies between 0 and 360. Now, notice, it includes 0 and it includes 360. So if the answer is 0 degrees, I'm going to have to write down 0 degrees, comma, 360 degrees, right? Because it includes both. It's less than or equal to on both. A lot of times you might just see strictly less than 360, then you'll only say 0, right? We want to mess with you, we could put the strictly less than here, so you got to put 360 and not 0, right? So you got to read the restriction, right? So look at the restriction, just say, okay, there's restriction, right? When does it matter? Only if it's 0 or 360, otherwise just normal, we're just going to stick with the unit circle. So cos theta is equal to √3/2. So what you want to do is look on your unit circle and say where cos theta is √3/2, which is where the x coordinate is √3/2. So what's the answer? Okay, so you just look at the unit circle, you're looking for an x value of positive root 3 over 2. It happens at 30 degrees and 330 degrees, right? Here's another way to do this. Using the first quadrant of the unit circle, reference angles, and the cast rule. Okay. So here's what you do. You say the cosine, so first of all, cast rule. Actually, cast rule. All science teachers combine, whatever, right? The ASTC rule. Add sugar to coffee. Not bulletproof coffee, it doesn't need it, but Tim Hortons coffee or Starbucks coffee. That stuff's bitter. Okay, so where is cosine positive? Okay, quadrant 1 and 4. So remember the quadrants, right? 1, 2, 3, and IV. It's as easy as 1, 2, 3, IV. Okay, so we know that we need to be in the first quadrant or the fourth quadrant. We have memorized the first quadrant of the unit circle. So we say, okay, cos theta is root 3 over 2. First quadrant of the unit circle, theta is 30 degrees. The first quadrant angle is also known as the reference angle. So I need a reference angle of 30 degrees in quadrant 4. What do I do in quadrant 4? So theta, let's say theta r. My reference angles, let's just go with reference angle, right? Because here, I'm going to need a reference angle for this, right? Because it's negative, and then we'll worry about what it is. So you start off by just figuring out, ignore the sign, S-I-G-N sign, right? Not the sign. Ignore whether it's positive or negative. Just say, in quadrant 1, what angle gives me root 3 over 2? 30 degrees. That's my reference angle. Now, because this is positive, by the cast rule, we are looking for a quadrant 1 angle and a quadrant 4 angle. Okay? So we look at it, we say, if this is positive, what's its reference angle? Then we look at it and we say it is positive, so it's in quadrant 1, quadrant 4. And then we say the quadrant 1 angle just is the reference angle, which is 30 degrees. And the quadrant 4 angle is 360 degrees minus 30 degrees, which is 330 degrees. Okay, so then our theta is 30 degrees and 330 degrees. Okay, so we'll do this for the rest, right? Because it's a lot easier to draw out the first quadrant of the unit circle, write down CAST, and just work stuff from there than it is to draw out the entire unit circle and then have to sit and look. So, cos theta is a half. So, first of all, which quadrant?
Negative.
It's negative, so it's quadrant 2 and 3, right? So I need a quadrant 2 angle, quadrant 3 angle. What's my reference angle? So just looking at quadrant 1, what angle gives me a half? 60 degrees. So my reference angle is 60 degrees. I need a 60 degree reference angle in quadrant 2. So what is it? So it's 180 degrees minus 60 degrees, which is 120 degrees. And I need a 60 degree reference angle in quadrant 3, which is 180 degrees plus 60 degrees, or 240 degrees. So theta is 120 degrees and 240. Now go flip back to your unit circle and say, wow, it really is. Right? Like, that's amazing. That actually worked. Okay. So that's the line of reasoning you want to go through, right? And we're going to do like 4 more. And then are we done after these? Or is there more? There's more. There's always more. Okay. Sine theta is negative. Where is sine theta negative? Q and 3 and 4. Okay, so cast rule says sine is negative in quadrant 3, quadrant 4. Ignore the fact that it's negative root 3 over 2. What is the reference angle? 60 degrees. And let's just go straight to the answer. So the quadrant 3 angle is, and the quadrant 4 angle is 300. Okay? So you got to get to the point where you're just doing reference angles in your head, right? Say, okay, quadrant 3 is 180 plus. So you got to remember, quadrant 2 is 180 minus. Quadrant 3 is 180 plus, and quadrant 4 is 360 minus. Okay, sine theta is 1 over root 2. Where are we? Quadrant 1 and quadrant 2, right? Sine is positive, Q1, Q2. 1 over root 2. 45 degrees, right? It's like, who did 1 over root 2, right? It should be root 2 over 2. That's fine, we can work both ways. So my reference angle is 45 degrees. What's my angles? Quadrant 1 angle is 45. Quadrant 2 angle is 180 minus 45, or 135. Tan theta is negative 1. Where is tangent negative? 2 and 4. What's the reference angle for 1, for tan theta being 1? 45 degrees, right? Okay, so what are my angles? Okay, just do your reference angle work, right? You need a reference angle of 45 degrees in quadrant 2, 180 minus 45. It's okay, you can use a calculator. And 360 minus 45. You get to the point where you won't need a calculator because you'll know those angles, right? Like, there's only... Okay, tan theta is root 3. It's positive. Where are we? Okay, remember, as far as answering these questions, if you have a unit circle in front of you, you don't need to worry about doing this stuff, right? I'm just trying to, having taught you the unit circle, now wean you away from it, right? Like, yeah, you can do the whole thing, but really? Don't really need it? Okay, reference that. What are we looking for? We're looking for y is root 3 and x is 1, right?
60 degrees.
60 degrees. So we say theta r is 60 degrees, so what's theta? 60 and 240. Yeah. Honestly, I know that the sine of 30 degrees is a half. I could do everything from that number. Like, I seriously can, right? And I can show you how. I'm not going to, not this year, but maybe next year. But if you know the sine of 30 is a half, everything comes from that, right? Because then the cosine has to be that number that goes with a half, which is root 3 over 2. Okay, so that's 30 and that's 60, right? Because sine 30 is the same as cos 60, so cos 60 is the same as sine 30, right? So if I know sine 30, I know cos 60. If I know sine 30 is a half, then I know that cos 30 is root 3 over 2, which gives me the sine of 60, right? So now I know sine 30, which gives me cos 60. I got to get the root 3 over 2, gives me cos 30, which gives me sine 60. The 45s are the other numbers, right? So cos 45, sine 45, both root 2 over 2, and then I get 0 and 1. That's it, right? Sine 30 is a half. Just know that. Last thing, this is the last thing, right? Express each of the following in terms of the trig ratio of the reference angle and evaluate. Express answers as an exact value. Okay, so the cos of 120. What's the reference angle for 120? 60, right? It's like, so 120 is a second quadrant angle, 180 minus 120 is 60. So cos of 120 is equal to the cos of 60 degrees, right? Except what? 120 is negative and cos 60, so, well, we got to say this is the negative cosine of 60 degrees, right? So 120 is the same as negative cos 60. The negative of cos 60. And cos 60 is the same as sine 30, right? So it's a half, so it's negative 1/2. Sine of 240. Okay, 240, quadrant 3 angle. What's the reference angle? 60. But 240 is quadrant 3, so what do we know about the sine in quadrant 3? So it's the negative of the sine of 60 degrees. Well, if the cos of 60 is a half, then sine of 60 is root 3 over 2, so this is negative root 3 over 2. Okay, remember, all you need to know is the sine of 30, and then the root 2 over 2, root 3 over 2 stuff, right? Tan of 135, what's that equal to? Okay, tan 45, but it's negative, so quadrant 2, right? So it's the negative of the tan of 45 degrees, which is negative 1. Okay? So you'll come to know these angles, especially by June 5th. You better know these angles by June 5th, right? Cos of 225. Okay, 225 is quadrant 3. Cosine is negative. So it's the negative of the cosine of, and the reference angle is? So 180, 225 minus 180 is 45 degrees, right? Negative root 2 over 2 or negative 1 over root 2, you know, it could be expressed either way. Same deal, you get 1 over root 3 or root 3 over 3, you just got to look at them and say they're the same. Right, if I see negative 1 over root 2, I just say, oh, that's the same as negative root 2 over 2. Sine of 330. Okay, 330 is a quadrant 4 angle. In quadrant 4, the sine is negative. 330 has a reference angle of 30, and the sine of 30 is 1/2, right? Because that's the only thing I really know. And I just build everything out from there. And the tan of 210. 210 is quadrant 3. Tangent's positive in quadrant 3. Reference angle for 210 is? So it's the same as the tan of 30 degrees, which is 1 over root 3 or root 3 over 3. I kept writing this as the... Yeah, we're done. In only 47 minutes.